So we're going to take what we learned from slope and from intercepts. We're going to use those tools to graph lines. To get started, let's talk about graphing using intercepts. So I'm just going to go right into examples. So we want to graph 3x minus 4y is 12. And we want to graph that by plotting the intercepts, which means we have to find them. So before we start with graphing, let's find the intercepts. So the x-intercept, recall, you got to plug in 0 for y to find the x-intercept. So if y equals 0, then that gives me 3x is 12 because negative 4 times 0 is 0, so that term goes away. And if I divide both sides by 3, I get x is 4. And that gives me my x-intercept of 4, 0. To find my y-intercept, we're going to plug in x equals 0. And when I plug in x equals 0, 3x goes away, and I get a negative 4y is 12. If I divide both sides by negative 4, I get y is negative 3. And that gives me 0, negative 3 for my y-intercept. So if I want to graph this, let's get some axes here. And I want to plot 4, 0 and 0, negative 3. So let's do 4, 0 first. 1, 2, 3, 4. And then 0, negative 3 is right there. I have my 2 points. I can connect the dots. And there is my graph. So when you have something that's in standard form and you're asked to plot with the intercepts, it's actually pretty straightforward. Make sure you're following the directions. If the directions say to plot by or graph by plotting the intercepts, you have to use intercepts. If you have other points, it's going to mark you wrong on your homework software, or you could get marked wrong on a test as well. So the intercepts, let's label them for 0 and 0, negative 3. And there we have a nice graph. Every now and then I see this show up in books and on, out when people are doing work with algebra, they're asked to plot intercepts and graph. And I'll see an example like 2y is 3x. And lines like this are a little funny because if you plug in 0 for x, then you get 0 for y, and it only has one intercept. And that would be 0, 0, the origin. And that can get confusing if you're told graph by using intercepts because, hey, I just said you need to plug in both the x-intercept and y-intercept, or plot the x-intercept and the y-intercept on the graph. And, well, this equation only has the origin as its only intercept. So what do we do? Well, you do need 2 points to plot a line. So in this case, you will have to use some other points. Actually, I made a mistake. That should have been a 6x. So I apologize. I didn't do anything else with it, so we don't have to change anything. That's 2y is 6x. What I'm going to do with this is I'm going to solve this for y. So 2y equals 6x. If I divide everything by 2, I get y equals 3x. And we can use a table to figure out a point. So I already know that 0, 0 works. And we just need one more. And if I plug in 2 times 3 is 6. So I have a 0.26. So let's go to 2, 6. And there is my line. And normally, like I said in previous videos, I like to use a straight edge. They just don't cooperate on a tablet. So now we're going to graph by plotting a point and using the slope. And this can be done with any point. You can start off with any point and you can generate extra points by using the slope. And it's really just counting off. So 1, y is 2x minus 3. And so we need a point to start with. And if we're not given one, we have to plug in a value to get a point. And in this case, let's plug in x equals 0 to get the y-intercept of -3. So and I wasn't told to use the y-intercept. Sometimes you are, sometimes you're not. In this case, it doesn't matter. I just decided to pick it because it's a pretty easy point to start with. So if I plot my y-intercept of 0, -3, I can use my slope to get to my next point by recognizing that m is 2. That's also 2 over 1. And this is rise over run. And so that means I have a positive slope of 2. That means I'm going to go up 2 units and right 1 unit. So if I go up 2 units and right 1, I get my next point, which is at -1. I'm sorry, 1, -1. I can keep doing this by going up and over, up and over, up 2 over 1, up 2 over 1. I can get as many points as I want really quickly this way. And this actually ends up being a preferred method for a lot of students because it really quickly generates a lot of points in a straight line. So there's a couple things about that. It works great if you found the correct starting point, and any point on that line is a good starting point. The other thing is it only really works when you have a nice slope. And so I have a slope of 2, which is 2 over 1. If I have a fractional slope, which I'll see in the next example, it's not too bad. But in the real world, when you're trying to graph lines that fit like a data set or something like that, you're going to get y is -0.31x plus 42.78 or something ridiculous like that. It's really hard to use that method to graph lines in the real world. And so we need other techniques for things like that. And we'll talk about them as needed. Okay. Last example for this lesson. Let's look at y is -1/2 x plus 5. And I'm not going to use a y-intercept this time. So if I plug in 2 for x, I'm going to get -1 plus 5. That gives me y is 4. And so I'm going to start with 2, 4. And I'm going to use my slope. So if I'm starting at 2, 4, m is -1/2. And I can think about that in 2 different ways. That's -1 divided by 2. And it's also 1 divided by -2. So what does that mean? Well, if my rise is -1, that means I'm going down 1. And if I have a positive 2, that's right 2. So to count, I'll go down 1 and right 2. Down 1 and right 2. So I generated a couple points that way. Now, if I look at 1 over -2, and sometimes it's useful to do this, that's a rise of 1, but left 2 because negative is associated with left. So that's up 1 and left 2, up 1 and left 2. And hey, wait a minute, those are still on the same line. So I got a bunch of points that work. I'm going to draw my picture. And there we go. And that is how you graph using the slope and points.